This is about the Mr. Palmer fakie about projectile motion. And here's number 10. Go and read the information. I know you can read, so I'm not going to bother reading it to you. We know that the initial velocity is 0, and we know the acceleration from gravity is 9.81 meters per second squared. Now we come to kind of a judgment call. Is the distance negative or positive as it travels from the car traveling sideways to the bottom of the bucket? And here I have chosen to make it negative. That means that when we get a negative times a negative, we end up with a positive answer. So it's a bit of a judgment call, and I don't personally want to argue about it too much. Let's not make this into a big deal. I'm fine with either way, honestly, if we get a negative answer or a positive answer, because remember, in this case, it's just a direction. The negative sign is just a direction. So do we want to consider that the velocity is a positive, or that we're showing the negative sign that shows that it's dropping? I think maybe some of the super physics teachers would want the velocity to be negative at the end, but that also means that you have to say that its distance is a positive. So I don't know. I'm kind of done arguing about it in my mind. I'll take it either way. So this times this times this is this. Remember that the meters multiplies in here and gives you meters squared over seconds squared, and that's a good thing because we're going to have to square root our answer to get VF, and so the square root of this units squared is this units not squared, and this is our vertical velocity downward only, not considering the travel to the left or right along the horizontal plane. So what is the velocity along the actual path of travel? And we can use the Pythagorean theorem. We just found the vertical drop, the vertical speed in the y plane, so to speak, and we already know the speed in the x plane because it's stated in the information. So the hypotenuse squared is equal to the one side squared plus the other side squared, and we can solve for the hypotenuse, and that's the real velocity along the hypotenuse. So what angle is that, though? Because this is merely a speed, it's not a vector because it doesn't have a direction yet. Well, I know the y component of the overall velocity is this because I solved it back in 10, and I was given the horizontal component in the horizontal plane. So the tangent of this angle must be opposite over adjacent, and I can take inverse tangent of that and get the angle here. For 16, again, read the information. I know you can read, so I won't bother reading it to you. Just hit pause and go read it. We're given an angle and an initial velocity along that angle. So that's essentially the hypotenuse of the triangle. And I know it's going to curve, but if we just take that first moment when it's, so to speak, not curving, we can stretch that out and make it a hypotenuse, and then we can find the y component and the x component of that triangle. And so sine of 40 degrees would be y over that, opposite over hypotenuse, and then we can solve for y. Cosine would be adjacent over hypotenuse, so x over that, and we can solve for x. Now the x is the speed for the horizontal plane of travel. So that's very simple. We're not fighting gravity with that part, so it's just distance equals velocity times time. Now the one trick is to make sure that that turns into 1 meter, because when I did it the first couple of times, I didn't turn it into 1 meter. So make sure you do that correctly, because I didn't. 100 centimeters is 1 meter, and then we can divide it and we get the time for the travel. If we know it's going to go this far, then it must, at this speed, it must take a certain time. And that time applies to any component of this travel, right? The one object does not have 2 times of travel. It only has 1 time of travel. And that's the point that Mr. Palmer was making in one of his videos, that the time switch hits, it can go in any component of these calculations because one object only has 1 time of travel. So what's the height vertically if we use that time of travel? Well, I know its vertical speed because I found that out here. Its initial velocity. I know the time of travel because I just found that out here. And I know the acceleration from gravity. Make sure to put negative. Otherwise, you'll add this and you'll get the wrong answer. And this times this is this. this times this times this. Remember to square that, because my big mistake has been not squaring it. I've done that one too. So squared times times, and that's this. Make sure that you have a minus sign and subtract, and that's the distance compared to the launch point. And since we got a positive number, it's the distance above the launch point. Here's 19. Again, you can read the information, so I'm not going to bother reading it to you, but Captain America kicks the ball at 200 meters, and then he wants to kick it at 240 meters, but he's already kicked it as hard as he can, so we can't change the speed. So let's go find the speed. If he kicked it 200 meters, then VI squared is unknown. We're going to go find the speed first. And the 2 is times the angle before you take the sine of it. And I did it wrong myself at first. And I said sine of the angle times 2, but it's sine of 2 times the angle. So make sure you get that right. Over the acceleration due to gravity, and that turns out to need to be a positive. And I actually had someone walk me through the whole derivation of this thing, and by the time we got done, I said, oh my gosh, it is a positive. I know that I've said, hey, gravity needs to be negative or else you get the wrong thing, but in this equation, because of the way it's built, it actually is a positive number. Don't stick a negative on that. So we're going to take sine of 50 divided by 9.81 and then multiply that by 200. We're going to get meters squared over seconds squared, because when this multiplies, that this unit multiplies by that, we get meters squared per second squared. And then we got to take the square root. So that's why this is squared, because we're going to have to take the square root. And we get 50.6 meters per second. So that's the speed he must have used if he used this angle to get that distance. Now he's going to kick it again. He's going to change the angle, but he can't kick it any harder. So we're going to borrow that speed and put it back in for VI. Now I know VI. I'm not asking the equation for VI. I know VI. I'm asking it for the angle, and this gets a tiny bit trickier. So let's square this, divide it by that, and then here I did this mistake. Take that answer and divide it under 240. I would go and get your calculator and actually do this, and I got 0.919. Now, take the inverse sign first. So let's take, some people would say arc sine, inverse sine. On your calculator, you may have inverse, second, shift, and then I would put answer because I assume that's already there. So you're going to say take inverse sine of 0.919, and I got 66.8. But that is equal to double of the angle. So then divide by 2, and we get the angle that is theta. And that's the angle he has to change to if he's going to go 240 meters with the ball using the same speed of the ball off the foot.